Let's get a grip on tangent here. Tangent's kind of a different animal here. Let's first look at that tangent identity here that we're going to use. One thing that I notice about the tangent identity is that it kind of does a mix of this whole plus minus stuff and then the minus plus there, so we're going to have to watch out for that. And one thing that isn't exclusive to tangent, it could show up on sines and cosines, is the fact they give us a radian measurement here. Now, if you're uncomfortable dealing with radians and getting pi over 12 using unit circle values, I think it'd be pi over 4 minus pi over 6 to get us to pi over 12. It's not as easy to recognize as if we were doing this in degrees. So how do I do this in degrees? Well, think about pi as just being 180 degrees. What's 180 degrees divided by 12? Yeah, it's just 15 degrees. So when I see this one here, I just picture tangent of 15 degrees. So breaking tangent of 15 degrees down, we'll have tangent of 45 degrees minus 30 degrees. Pretty straightforward. So let's throw this right into that tangent formula here. We have tangent of 45. Let's fill the rest in here quickly. There we go. One thing to notice here is that because this was minus here, it's actually the bottom symbol. So we use bottom symbols throughout there. Okay? So let's continue here. Let's use our unit circle here and figure out tangent 45. Well, that's 1, isn't it? Minus tangent 30, which is the square root 3 over 3, all over 1 plus tangent 45 is 1 times, wait a second, we're just going to have 1 times the square root 3 over 3, right? So wouldn't that just be the square root of 3 over 3? Great. So here we go. Here's how we need to properly do the rest of this simplification. To complete the rest of this simplification, what we have to understand here is that in the numerator we have 1, 2 things here, and 1 and 2 things here. A lot of students love to go straight to it and try and multiply by the reciprocal because they see fractions within fractions. Unfortunately, that's the wrong way to go. We can't just pluck out that square root 3 over 3 without any respect to that 1 right there. Just can't do it. So what we need to do now, first, before we multiply by a reciprocal, is let's turn this into one fraction. Now 1 is a pretty moldable fraction when you want to get it to match any other fraction, right? What we're going to do with those 1s is why not, let's write those 1s as just 3 over 3. Why 3 over 3? Because we see a 3 in the denominator over here. 1 is easily moldable. If this was a 7, we'd say 7 over 7. If this was a 12, we'd say 12 over 12. 1's great like that. Good to go. Ubiquitous. So now let's write both of these now as one fraction. So there we go. 3 minus square root 3 over 3, and then over 3 plus square root 3 over 3. Now, when we have it as a single fraction divided by a single fraction, it's now pretty straightforward now that we're going to take this and multiply by the reciprocal. Do you notice what's going to happen next? Those 3's are going to take a hike. Now can we cancel these 3's here? No! Can we cancel the square root 3's? No! That plus sign, that minus sign stopping us from doing that. So let's look at what our new fraction is going to look like. We'll have our 3 minus the square root of 3 all over 3 plus the square root of 3. Now you pre-calc veterans know that there's still an issue here with this simplification. Haven't fun yet? And what that next simplification move would be is rationalizing that denominator because we have a square root down there. Now your first instinct might be saying, hey, let's multiply both top and bottom by the square root of 3. But because this is a quantity here, realize we cure our ill here when that illness is just going to pop up again someplace else. That's no good. So just this quantity alone, square root of 3, isn't going to cut it. We're going to need something beefier. Well, maybe, what if we tried all of it that was down there? What if we tried 3 plus the square root of 3? Now, if we think like a chess player and think a couple moves ahead here, when we have to FOIL this here, notice first times first will give us 9. Last times last will give us 3 because the square roots cancel out, giving us 12 there. Hooray! But wait a minute. Inside we'll get 3 square roots of 3. Outside we'll get 3 square roots of 3. We'll have 6 square roots of 3. Ah, nuts. That still doesn't cancel out. So now what? I got an idea. What if we didn't make it 3 plus the square root of 3? What if we made it 3 minus the square root of 3? Taking a page out of multiplying by a conjugate that we did with imaginary numbers. I think that'll work. So let's FOIL. And distributive property here with this stuff up here and with this down here. If we just write out everything here, we'll have 9. Outside would be minus 3 square roots of 3. Inside would be a second 3 square roots of 3, keyword second. And last times last, a negative times a negative makes a positive. Square root 3 makes a 3. Down below, we'll have our 9 again. Outside gives us negative 3 square roots of 3. Inside gives us a positive 3 square roots of 3. Those are going to add up to 0. And then positive square root 3, negative square root 3, negative 3. Whew, we're almost done with this thing, I promise. Cleaning this up, looking for like terms here and here, and like terms there and there. What we'll get here is 9 plus the 3 will give us the 12. And then negative 3 square roots of 3 minus 3 square roots of 3, we're down 6 square roots of 3. All over 9 and 3 minus 3 gives us 6. And then look at that, the square root 3 square roots of 3 and the negative square root 3, 3 square roots of 3, those add up to big 0. Oh, we're so close. Notice now that we're dividing by a monomial like 6, we can just divide each one of the 2 terms up here by 6. When I divide the 12 by the 6, that's easy, it's just 2. 6 square roots of 3 divided by 6 is just going to reduce the 6's out there, leaving us with a square root of 3. Shoo! Finished. There's got to be a shorter way, right? There's got to be a shorter way. Look at all this work. It's tough to remember what the original question was. It was a tangent of 15 degrees. Well, maybe there's another way we could have done this. Isn't it true that the tangent of 15 degrees is the same as the sine of 15 degrees over the cosine of 15 degrees? Yes. Now, wouldn't that mean we'd have to bust out the sine formula and do, I don't know, 45 minus 30, and cosine and do 45 minus 30? Tick-tock, tick-tock. Hey, wait a minute. I think we did both of these already. The sine of 15 degrees. It was right there. We did it earlier on our note sheet. Well, what about the cosine of 15 degrees? We did it. It was right there. So let's put those back into that tangent problem. Alright, so the sine of 15 degrees, I believe that was the square root of 6 minus the square root of 2 all over 4. Cosine of 15 degrees, that was the square root of 6 plus the square root of 2 all over 4. Hey, do you notice that we have a single fraction over a single fraction? So now we can multiply by the reciprocal right now. So if we do that, we had 6, a square root of 6 minus the square root of 2 all over 4 times the reciprocal of this right here, which would be 4 over the square root of 6 plus the square root of 2. See a 4? Leaving us with the square root of 6 minus square root 2 all over the square root of 6 plus the square root 2. Need more room? Hey, boy, we lined this up quite nicely, right? Remember right here when we had this, I multiplied top and bottom by that conjugate? Let's do the same thing here. Let's multiply top and bottom by square root 6 minus the square root of 2. Square root of 6 minus the square root of 2. Alright, let's FOIL. Square root 6, that makes a 6. Square root 6 times square root 2, negative square root 2, that gives us negative square root 12. Minus another square root of 12. And then negative and negative makes a positive, and 2 and square root 2 makes 2. Down below, we have a 6 again. Notice inner and outer, bye-bye. And then we have minus 2. So simplifying this, bottom, easy, that's 4. This is not looking right now, but let's have some faith. 2, 6, and 2, that makes 8. And then, hey, wait a minute, I have 1 square root of 12, another 1 square root of 12. When I'm subtracting 1 minus 1, I'm going to have 2 of those square roots of 12s. Still doesn't match. What gives? I think I know what's going on here. Notice that square root of 12? Can't we simplify that square root? In other words, square root 4 times square root 3 gives us that. Let's multiply those two 2's together. And then let's reduce each one of these by dividing by 4. Oh, I know what's going on here. Well, it wouldn't be a 2. Still doesn't match, but if I look carefully at what I did over here, all of a sudden my minus sign turned into a plus sign. That's no good. Some of you guys are probably looking at that when you were watching the video earlier. Much better. Hey, look, match it up. Look at that. So, the choice is yours. Either treat the tangent problem like it is using the tangent identity, or make it a sine and cosine problem, because who knows, maybe you did these ones earlier on in your work. Alright?